Give me the nod when. Cool. Okay, well, I've been in the industry for 21 years now, and you can probably guess from kind of my careworn features. And even nearly 20 years ago, we were using things like Java, C#, and JavaScript to deliver systems. I mean, the languages have evolved, but there's a whole world of other languages and technologies out there. And actually, if you look at things like smartphones, I mean, we didn't really have them 20 years ago. So the whole technology landscape has changed so much, yet we seem to be kind of stuck using these relics from a bygone age. And I thought, well, why is that? And those are the thoughts that were the seed of this series, really. Do you want to move on one, please? Thank you. So today, we're going to, first of all, do a brief introduction to AND, try and keep that as brief as possible. And I'm going to talk a little bit about the term challenger languages and which ones they are and what we've selected for this series. And then I'm going to hand over to Ruth, who'll do the rest of this talk, and she'll give a history and a bit of summary of Kotlin and a great live demo and some pros and cons, some of your next steps. And there'll be a bit of time for questions at the end. But first of all, before we start, kind of who are we? Well, I'm Jeff Watkins. Move on, please. Thank you. I'm Jeff Watkins. I'm Digital's Chief Engineer. Currently not signing a shirt, and because I'm at home, obviously, like the rest of us. And also today, Ruth, do you want to introduce yourself?
Yep, I'm Ruta. I'm an associate and digital. We have and titles at and, so mine is old lady. I like knitting and jigsaw puzzles because I'm a bit sad. Not much else goes on in my life. And I will be helping with the challenger languages today and talking about Kotlin.
Okay, well, first of all, just briefly, who are AND Digital? I'm sure many of you have heard of us, but for those who haven't, we're a technology and product-focused digital consultancy. We're around 720 people now, so we've actually grown quite quickly. I think we're about 6 years old. Majority of these people are actually in delivery roles with over 300 technologists, so actually this is kind of really close to our heart. And digital also technology agnostic. So when it comes to looking at language and tech, we're always keeping our eye on the industry and saying, well, which way is the wind blowing, really? You know, we help our clients navigate the change in the industry and digital transformation. So we can kind of help them build the right products for their users and upskill their teams simultaneously. So we actually do this through 3 elements to our business. And there's a more traditional kind of consultancy arm, which we call Guide, which is demystifying digital transformation. We sort of produce pragmatic strategies, really focus on driving action. And we look at kind of product, technology, people, delivery, and insight as part of that. But then there's the largest part of the business, which is what we call Build, which is effectively equipping people's in-house teams by working collaboratively with them to build technology, products, and delivery expertise internally. The kind of things they need to ship better digital products and services at an accelerated pace. And then there's the teach element, which is helping clients to develop their own digital talent. We want to bring digital skills and help close that digital skills gap for tens of thousands of people as part of our goals for 2025. So we believe that rather than a land and expand approach, we believe in building up capability within our clients, and we want to build up more responsive, resilient teams for a better tomorrow. Do you want to move on? Thank you. So although we are in difficult times right now, and digital is continuing to grow, and we're in exciting new work and new clients, and obviously get business from existing clients as well. We've got work in the public and private sectors within different markets, retail, utilities, finance, and healthcare. So if actually you're involved in one of the kind of roles that are on the screen right now, I'm not going to read them all off to you. There's a QR code there, or you can go to and.digital/join, and you can get in contact with us if you would like to work with AND Digital. I mean, we have offices in Edinburgh, Leeds, Manchester, Halifax, a few offices in London, Reading. And we'll continue to expand across the UK and into Europe. So if you're interested, just drop us a line. Just a little bit of housekeeping before we start. We're recording this webinar, as you quite probably noticed. If you don't want your face recorded, just turn your camera off, please. We'll probably take screen grabs of attendees or any cameras that are on at some point. So if you don't want that, please drop us a line. And generalized kind of code of conduct here. We like to run inclusive and safe events. I'm not going to read all these points to you again, but we're here all for the love of technology, and hope we're going to have some fun exploring some interesting tech over the next 5 and 11 events. Please try and keep all kind of questions and discussion respectful, and I think that's really all I need to say about that. Now, just trying to stay on mute during the talk if we can, because we've got a lot to get through in not a lot of time. There's a chat pane. If you look at the bottom of the chat pane, if you have questions, I encourage you to put as many questions you like into there. We'll try and answer some of those questions at the end. If you do have to dash 11:45 and dots, fine, but we might overrun in the questions area by a few minutes. So without further ado, I'd like to introduce the speakers for this series. So obviously, Ruta here today, talking about Kotlin. On the 23rd of July, there's George Mackay-Shaw, who's going to be talking about Rust. I'm going to be doing one on TypeScript on the 6th of August. David Johnson's going to do one on Go on the 10th of September. And finally, Shahid Azim is going to do one on Clojure on the 24th of September. And all the speakers, we've put taken upon ourselves in our spare time to learn more about these languages, so we can show some of the features. I think there's a really interesting set of demos that come out of this. Each one of them will have a live code demo. There might be hiccups. Please just sort of bear with me on that. Never work with live code, children, or animals. But why are we even discussing challenger languages, and what does it mean? There's something called the Toby Index. It's one of the most popular programming language indexes in the world. There are other ones. There's RedMonk, and there's, I think it's called Pipple as well, and there's obviously the Stack Overflow Index. Basically, these tend to aggregate searches, GitHub, check-ins and things like that, and they look at what's most popular. And in the case of Toby, you can actually see, quite interestingly, C is the most popular, sorry, the most used language, not necessarily the most popular. And up there we see, well, there's Java, obviously, and there's C#, and there's JavaScript, and there's a bunch of other things in there. But quite a lot of these languages are not necessarily, there's not necessarily a good intersection between what we love to use and what we want to use and what we are using. And this is the reason why, as part of this Challenger Language series, actually Python isn't on there, because Python, if we look at if you just go on to the next slide, most loved, actually Python is up there, and also it's one of the most popular used as well, so actually it's not a challenger. So these are languages that are loved and wanted, but aren't necessarily in a huge industry use. People might use them in their spare time. People might use them for their own projects. People might adopt them on a small scale in the industry where they get away with it. So if you look at kind of almost, there was very little intersection that most loved, top 10 and most used. Rust is #1, has been #1 for a couple of years now. TypeScript is up there now. Kotlin and Go are there. Clojure is just out of the top 10. So actually there's not a lot of intersection between the two. If you can actually now look at the most dreaded, Java is up there, and C# just misses out. It just gets into the 11th. So actually, obviously, there's not a lot of intersection between our most loved and our most dreaded. And actually, there's probably more intersection between our most dreaded and our most used as part of the Toby Index, which is interesting. But why are there so many choices? Why do we have so many different languages available? Well, I think the answer is a lot of it's around context. It's how they're used. So before we go into the actual meat of the talk here, so there's a number of different types of language, and we'll cover kind of some of the bases as part of this series of talks. So we've got kind of interpreted languages like Basic and Lisp and traditional JavaScript before the V8 engine came along. And we've got compiled languages, most archetypically things like C and C++, but we've got Go and Rust in there as well, which we are covering as part of this. These are kind of, you build it and it kind of gets built to an architecture. And then you've got your VM-based languages where it's a kind of build once, run anywhere architecture, which usually means they've got some kind of intermediary virtual machine. So Java and C# are the kind of typical examples of those. But also got Kotlin and Clojure on there as well, which are languages that sit within these VM-based ecosystems, but are a bit more productive and modern. So just because you're using a particular style of language, could be it compiled or VM-based or interpreted, declarative, functional, object-oriented, actually it doesn't stop you from looking at alternatives. So I think with that in mind, I'd like to hand over to Ruta so she can talk to you about Kotlin.
Yep. Hello. Once again, I'm Ruta, and this is the first of the Challenger Language series, so we're focusing on Kotlin. Like Jeff mentioned, this is quite a short period of time to discuss a language, so I won't go into absolutely everything. It's just to give you a bit of a taster, so don't hate me if I haven't mentioned every tiny little thing. So before we go into what it is and what it does, let's step back and actually look at what the timeline of Kotlin has been. So Kotlin was only announced actually in 2011. So it's less than 10 years old. So if you compare it to something like Java, it's kind of almost like a baby. It's still fairly new and exciting in some ways. And in 2012, it was open source without Apache 2 license. It took JetBrains, I think that's 5 years. Yes, my maths is bad. 5 years to finally release its first stable version 1.0. And then it took Google only a year to announce official support for Kotlin in mobile development. This was a big boost for the language and increased its popularity drastically. And then last year, Google announced that Kotlin is actually the preferred language now for Android development over Java. Once again, boosting its popularity and for a variety of reasons that we'll go into during this talk. So, what is Kotlin? It is a strongly typed language, like many others, and like some not others. It's object-oriented with some functional features. So it's actually officially multi-paradigm. You can use functional programming in it, and it can be really nice, but you don't have to. You can go down completely different route. It's completely up to you. It is primarily for the JVM. That's where it comes from. That's where a lot of its benefits and pros come from. But it can also compile to JS and native. And it's open source and used by many large corporations. I've named Google, and there's a few up on there, and there's many, many others. So, why does it keep stopping moving across? So, use cases. As mentioned previously, mobile development for Android. This is probably Kotlin's biggest use case in the industry. It has the largest amount of support for it through there, but there are also other use cases such as server-side applications. So as of Spring 5.0, Spring has official support for Kotlin in server-side applications. We have JavaScript single-page applications, fairly similar with Scala JS, and it can also compile to native Windows, Linux, etc. So Jeff kind of mentioned most loved, most wanted, and dreaded from the 2020 Stack Overflow survey. But I want to step back a bit and look at the results from the previous year first. So the key to the creation of Kotlin, so when JetBrains created it, they wanted to focus on reducing noise and making things simpler. So they wanted to take the repetitive things you have to do in a lot of languages like Java and remove them to try and make a developer's life easier, right? So that was their aim. So if you look at the Stack Overflow survey, it looks into what language people like, what language people use, and Kotlin last year in 2019 came fourth in the most loved language. It also came fifth in the most wanted, so people want to learn to use Kotlin and people want to explore it and see how it can be used. Then if we go to this year, it once again has come fourth in being the most loved, and it dropped a bit to sixth in most wanted. So arguably taking JetBrains' ideals for Kotlin, they are looking at these results multiple years now in a row. They are doing well to achieve that. If it's continually being a highly loved language, evidently they're doing something right. They're making developers' lives easier in some way, shape, or form, right? So we're now going to do a terrifying live coding demo. Of course, the first rule of live demos is never to do a live demo. So please excuse any issues, but it's a fairly short one. So obviously, like I mentioned previously, I'm not going to go into every tiny little detail, but just give you a bit of a flavor for the language. So can everyone see my screen? I really hope you can. Yeah, brilliant. So I'm going to use IntelliJ for this, which is also created by JetBrains and makes sense if we're using Kotlin. And of course, no demo or code example of a language ever starts without a hello world program, right? So here we don't have Kotlin here, we have Java. Very typical hello world example in Java, right? We have our public class called hello world, and we have our main entry to the program with public static void. Main takes in arguments and then prints out to the console hello world, right? And when it will run, it will print us out hello world. Wonderful, nice and easy. So let's write it in Kotlin and just see what the main differences are, right? So I'm going to quickly create a version and let me split it vertically so you can see it at the same time. And I'll type it out and then we can discuss. All right. And we'll do the exact same thing. We'll print out hello. Right. And here let me zoom in for you. So there are a few things to note here, right? There's a lot of similarities with Java. We have a main function, and that's our main entry to the program. If I run that, it will do the exact same thing. Fingers crossed. It will take in arguments as needed, and it will use println to print to the console, as you can see. But there are also some key differences here between the two. So first of all, there's no need for a class. You don't have to put a main function in a class if you don't want to. You can do if you don't have to. There's no public declaration before the main function. This is default. The public is the default for functions in Kotlin. There is no return type for void. You don't need it. You do need it for other return types, though. I will mention that later. No need for static. There's no such thing as a static variable, static functions in Kotlin. There's no need for system.out before the println, and there's no need for semicolons. You can put them in. They're optional. It will get ignored and it will grey out. So you can see there where there is a Java influence coming in, but also that reduction of noise that JetBrains have been focusing on. And as they keep saying, noise is bad for your brain. That is already beginning to seep in, even in this tiny little example. Right. So let's take it to the next step, I guess. Let me put it back to what we want. So here we have a typical Java class, a person class, and it's fairly basic. We have a name, that's a string, we have an age, we have our constructor here, and we have our typical getters and setters to use our variables, right? Now, we can rewrite this in Kotlin, and we can actually rewrite it in a very similar way. We can make it look almost exactly the same with the constructor. We can have our getters and we can have our setters if we so wish. But before we even consider doing that, let's just take a look at this as a whole. This is a class that has about over 20 lines, and it's not actually doing anything at this point, is it? It's boilerplate. It's setting things up for you to be able to use them at a later date in a different way. You can't, before even doing anything with this class, you have to set all this up. So instead of rewriting all this, and you watch me type really badly when people are watching me type because you forget how to, I'm going to use actually a built-in IntelliJ feature provided by JetBrains, and that is converting Java files to Kotlin. So JetBrains allows you to have your built-in Google Translate for your language. Now, this isn't always perfect, but it works really well in this example, so I will show you. So I'll do this and click that, and here we go. We have the exact same thing that we had in Java, but just in Kotlin, all in one line. What Kotlin has done here, once again, is remove noise, right? You still have your class, you have the variables that you need to var. Kotlin prefers having vals, which is equivalent to constants. But just in this scenario, because we want getters and setters, we have a var, so it's mutable. We have our variable name, and we have the type, so string and age, integer. So it creates for you your constructor. It has your getters and setters behind the scenes for you, which you would have to write out in Java. This means you're less likely to make mistakes. You spend more time actually doing the things that you need to do rather than setting everything up. So let's say we want to print out information from this object. Let's say we've created a person and we want to know this person. So in Java, if we did, so here we have the exact same thing that we had before, but I have my main entry to the program, and we have a person called Bob, and he's 23, and that's all wonderful. And if I want to print out Bob and I do Bob to string, what happens here is that we get the object reference number, right here, this lovely little number. And as useful as this may be, it is kind of like referring to your friends by their national insurance number. It's a way to identify them, and like it's useful in some instances, but generally you probably want to know their name and maybe their age more frequently than you refer to them by their national insurance number. So what you'd have to do in Java then is you'd have to go in and override the toString function to make sure it prints out like what you want it to, right? So what do we do in Kotlin? In Kotlin, you already have all this provided for you in a data class. Now this may seem like you have to do a lot of different things to get that functionality. And actually it's as simple as doing something like this. Adding data in front of your class, and suddenly it's a data class. And then what this does is actually provides to you all the things that you normally have to override in Java, such as equals, toString, hash code, etc. It provides out of the box for you for generic functionality. You can override it if you so want, you can customize it if you really need to, but generally, the general gist of what people mostly use it for, it's available for you. So let's actually see this happening. If we do function name, like we did before, and let's create Hannah. Yep. And we will create a new person. And then let's say 83. We have an old person here. We'll print her to the console. Right. And then we run this. And it did its thing. And here we go. We see Hannah's name and age as opposed to her object reference number. So it gives you more detailed information about this object without you having to go in and create this function yourself. Also notice, just while we're here, you don't need the new keyword to instantiate a new instance of class in Kotlin. It's not necessary. So I can also highlight the getters and setters that I mentioned earlier. So if I do Hannah.name, it will go in Kotlin behind the scenes, use the getter and setter for it, and it will print out Hannah as well. So another feature in Kotlin is extension functions. So let's say you have an immutable class or a third-party object, something like that, and you can't add functionality to it directly. If you want to extend the class with new functionality, in Java you might need to derive a new class, or you might have to use some kind of design pattern, right? So for example, let's take the string class. It's immutable, we can't change it. It's not really right for us to change it either. But however, let's say we want a function where that would remove the first and last character of every string that we put into it. So in the example of a person, let's say Hannah had a nickname and she preferred being called Anna. And yes, I specifically picked the name Hannah, so this example would work. So in Kotlin, we can use the extension function to extend a class with new functionality. It's a member function of that class, but it's defined outside of it. So it doesn't change the class, the original class, it just gives it additional functionality that you need for you. So let's see this in action. I will type it out and then we'll discuss. String, trying to import the string, and then we have the stop substring. Right. So what we have here is, this is the string class as the receiver type. We're saying, please add functionality to this class. We then added the name of the function, the functionality that we want, the function. And then we say that the return time of that function will be a string. And then what we want it to do, which is remove the first and last character. So if we then have val nickname and do Hannah.name.remove, oh, it's frozen on me, remove the first and last character, and do println nickname, we should get, when it reloads, Anna. And this actually, you can do this on any string, so just to highlight that, let's do hello world again, and then we do remove first last character. And it acts as if that was functionality already embedded in the string class for you. So this can be useful when you want to enhance, extend, or change an existing API. It can also be really useful with nullables. There's a lot of use cases for it. So and now, next I'm going to quickly go over null safety in Kotlin and what that provides us. So if we go back to hello world at in Java, sorry. And yeah, let's declare a string name equals null. And if we do name.length, we will then, when we run that, we will get a null pointer exception. Well, hey, the $1 billion mistake, eh? And the problem with this obviously is Java lets you run your code. It will run the program for you, and then it will crash and burn and die out of it. So what Kotlin tries to avoid here is it doesn't let you do that. So obviously, like Java with the IDE here, it highlights that length is going to be null and it's going to have an issue, but it won't stop you. It won't, like you can still run it and you might not notice in your code. Kotlin doesn't let you compile unless like if there isn't a possible null somewhere basically. So if we go to hello world in Kotlin, we'll add to this and say, let me create a string. Actually, I'll create a function. So let's create never null, which will be of type string, and we say this can't be null. So if we try and set this variable to null, it complains. It says null cannot be a value of a non-null type string. So even if we run this this program, it will not actually compile. And this is because by default in Kotlin, every variable is non-nullable. It has to be, it cannot be null. And it will complain if it is. But of course, what if we want a nullable string? What if we're, I don't know, getting a callback from an API and we can't guarantee that this will never be null. We can't guarantee that. What can we do in that instance? So what Kotlin has is a safe call operator. So it can be null. Let's do that. So it's a type string, but we say this can be null. Yeah. And this will run and it'll be absolutely fine. So this is the safe call operator, and it says there is a possibility that this variable could at one point or another be null. Let it, it's fine. So to highlight something else, I'm going to quickly create another function here, which will be called string length. It will take in a variable of type string, and it will return an integer. So we will return not null dot length. So all this does is obviously takes in a string that's not nullable and returns the length of it, right? So if we here do println and we do our never null and do string.length, oh, just gone a bit weird. It's not what I want. String length never null. This will be fine. And then if we try and put in the one with the safe call operator, what will happen? It will complain. It won't compile once again. It will complain because it says that this is a variable that could possibly be null. Even if we say we get rid of that, and we can see here that this variable is definitely not null. It does not accept it because we've told the compiler that this variable could possibly be null in one day at some point, possibly. So what can you do in this instance? We return to null. So what Kotlin has is the Elevenses operator, and it looks like this, with a question mark and a colon. And basically what this does is it says, use this original variable if it has it, but on the off chance that it's null, use this instead. And then it will compile, and it will run absolutely fine. And if this is null, it will just use this, as you can see. So, but maybe sometimes you really want your null pointer exception. Maybe there might be a case. So you can force it as well, perfectly fine. And what you can do, you can use the not null assertion operator. You're telling the compiler, no worries, don't you worry, I can assure you this will never be null. I know I've said it might be, but it won't be, promise, 100%, swear on my life. And then what will happen when you run it, it will compile, it will run, but you will then get your dreaded null pointer exception. So, last thing I'm going to quickly go over in Kotlin is lambdas and higher order functions. So, we go to here. once again, just another main function. So in Kotlin, we have lambdas, similar to many functional programming languages. So lambda is a code block with curly braces, an anonymous function that we can treat as values, right? So let me show an example of this. So let's take this. So it's grayed out because we're not using it, but all this is takes in two variables, x and y, of type integer. We have our arrow function, and then after that, we have the return value, so which will be x plus y. So it will return to us. If we put in 1 and 2, it will return to us 3. All right. So in Kotlin, lambdas are first-class citizens. So this means that they are values in their own right, and they can be passed around just like anything else would be. So a string, an integer, an object, whatever it is. So it means if we want, we can assign this lambda to a value, and it'll be perfectly fine. Once again, grayed out because we're not using it. So what this enables us to do is have higher order functions and make them really lovely. So this means that we can pass functions into functions, and we can return functions from functions. So a good existing example of this is the built-in Kotlin collections functions. Once again, similar to many other languages. All of these are higher order functions which take in lambdas or anonymous functions and apply them to a collection. So for example, let's take map. So if we create a list of 1, 2, and 3, and we print ln oh, the dreaded wheel of doom. Please IntelliJ, don't crash me. Ah, wonderful. And nums dot map, and then we have it. So what we're doing here, we use map, which just goes through each element in that list. And on each element, it applies this lambda. So it in Kotlin is basically itself. If a lambda or function doesn't have a what's the word? A parameter that comes into it, it will just use itself. And we're just timesing it by 2. So we're doubling each number. So if we run this, we should just, in our list of 1, 2, and 3 should be 2, 4, and 6. Voila. So, yeah. So this allows for greater reusability, and it's why the collection function is actually so useful. So another way of doing this is by assigning lambda to a variable or value. So taking the integer that we're getting from map, and we're timesing it by 2. And then num.map. Nums. Yeah, and it will do the exact same thing. We can shorten this down even further and get rid of this, and we can use this instead, and it will do the exact same thing. Yep. So many different ways of doing it. So once again, of course, this simplifies our code and focus on the reduced noise aspect. But what would this look like if we couldn't use higher order functions? Let's take the example of filter, another collections function. Let's say we had to do it all manually, and we can pass anything into each other. So let's say we want to take that list and grab all the even numbers from it. So we might have a function called getEvens, which would take in the list that has integers in it, and it would return us a list of integers, of hopefully even integers. And if we do a temporary list, mutable list of int, and then we'd have maybe a for loop, and then for each element in the list, if the element has doesn't have a remainder, so modulo divide by 2. If it doesn't have a remainder, add it to the list. Okay. And then what we do maybe is we return the temp list, and we then print out getEvens nums, and it will hopefully do what we want it to do. And yeah, and it prints out 2, and that's the only even number we have in 1, 2, and 3. But it does it with a lot more effort. It's kind of Java way of doing it. And like I said, it works, you can do it, but you're not leveraging the language to its full potential there. So with higher order functions, we can do something more like this. So once again, we're taking in the integer and saying take out anything that isn't even, and we can just do something like filter, and this will achieve the exact same thing in 2 lines of code instead of, what was that, just under 10. And does the same thing. And of course you can reduce that even more if you so wish. You can put that in there and have it in 1 line, and once again we'll do the exact same thing. So not only does this allow us to once again reduce noise, but it also makes our code more usable and versatile. So yeah, that'll be it for the code demo. Now we can continue with the rest of the presentation. Right, so a few of the language features that we've kind of gone through. We've gone through a snippet of them. We haven't gone through all of them. So we went through classes and data classes. So we can reduce boilerplate by not having to write in our constructors. Gosh, it's one of those days. Constructors and functions like getters and setters. And of course, data classes allow us also to have equals to string, hash code, etc. already all provided for you. Kotlin has null safety built in, so you can avoid the dreaded null pointer exception through the safe call operator, Elevenses operator, and of course the not null operator if you so wish. Lambdas are a first-class citizen in Kotlin, meaning they have value in their own right. You can pass them into functions and return them from functions, so pass them out like any other value. We have extension functions, so you can extend a class without inheriting from it. It's immutable and closed by default, so vals over vars preferably, which kind of didn't fully come across maybe in that. Inline function, so there's the option to have inline functions, so this stops functions that are being passed in continually being stored as objects, which is great. We have smart casts through is checks and to insert safe casts. We have string templating, so string interpolation is quite common in a lot of languages, but it's there as well if you want it. There's type inference, operator overloading is available if you so choose, and coroutines. So, what are Kotlin's main wins and losses outside of anything that I've highlighted so far? So its biggest win is its interoperability with Java. What this means is Kotlin and Java can work side by side and speak to one another like best friends, absolutely fine. You can have Kotlin and Java in the exact same code base, and it's not a problem at all. You won't have any issues. Kotlin can leverage all of Java's libraries, which makes it also really lovely and easy to migrate over if you so wish. Obviously, the second win is the reduced noise aspect. I believe JetBrains say that you're going to have about 40% less lines of code in comparison to Java if you use Kotlin. And I believe that's on their official documentation. So their whole focus is noise is bad for your brain. So they try really hard to make that come through and keeping things simple and not forcing you to do things manually that can be done for you, which is really what coding should be. We make other people's lives easier. Why not make our own lives easier? And it's backwards compatible. JetBrains has said that Kotlin will be backwards compatible to version 1.0, giving you extra safety and security. But it of course has losses. Nothing's perfect in this world, so we have a few issues. It's still fairly new, like I said earlier, comparing it to Java, which has been around for well over 20 years. Kotlin has been around for less than a decade. There are still teething issues. They are still learning from it. And also its use cases are changing. So there's a lot that can possibly go wrong, but they have a lot of support for it. They listen to the developers and say, who mention what they don't like. They listen to what isn't liked in other languages, and they try and clear that up and make it easy for fairly frequent updates. There's also a learning curve in the Kotlin. In particular, if you come from a Java background, it's very easy to write Kotlin in a Java way. You can do, like I said, it functions perfectly fine, but you're not leveraging the language to its full potential. You're not leveraging the language to its full potential. And lastly, most resources point to Android. Obviously, with Google announcing that it's ground support for Kotlin, it did kind of pigeon some of the resources a bit. When you start looking at things in Kotlin, it's very easily see on Stack Overflow things that point to Android, blog articles, lots of YouTube videos, everything kind of at first glance seems like it points to Kotlin. to Android. But there is actually a lot of, on the flip side, there's a lot of official documentation that focuses on other use cases as well, both provided by JetBrains, as well as like the Spring documentation as well for server-side Kotlin. There is a lot of things out there. You just have, it's probably not the first thing on Google, so you kind of have to think about it. But yeah. So the key points. So I wanted to highlight that Kotlin doesn't try to replace the Java ecosystem. They work completely nicely together. Although arguably, because it's trying to reduce the amount of pain Java can cause, maybe it is trying to replace the Java ecosystem, but not all at once. You don't have to completely bin off Java instantly. And like I mentioned before, JetBrains works really hard to make Kotlin as easy to adopt as possible. They listen to people's feedback and they have updates fairly frequently on that. So they try to make it better every day. So what's next possibly for you? So if you work on a JVM-based project, you can actually quite easily add Kotlin support. Like I said, you don't have to, like it says on the next point, you don't have to rewrite the entire world. You can take one file at a time or one area of your code base, and you can use first of all the IDE translator, and then you can edit it and change it accordingly. It can help you refactor. It can help make your life easier in that sense. So you don't have to change the world overnight. You don't have to bin your legacy system and start it all over from scratch and think of the pain of the years that might take to rebuild. You can just slowly migrate it over as and when you come to each section. Yeah, and that's it. Any questions? I don't know what
Thank you very much, Ruta. We've got one on the group chat that Fiora has already kind of answered with some resources, but from your experience, what are some of the best places to learn Kotlin if you're coming at it for the first time?
So other than obviously the usual YouTube blog post, Udemy courses, I haven't seen what's been actually responded in Zoom, so I'm sorry if I cover the same thing. So JetBrains' documentation is absolutely fabulous. It has use cases outside of just Android development, covering server-side, web development, data science as well. They also have JetBrains Academy, so that's a bit more interactive. It has like tutorials and it actually gives you like projects to work on, ranging in different difficulties and different things. It's quite fun, but I think they may have just started making it a paid thing, so I'm not sure, but I'm sure they have a free trial. But also, if you're focusing on learning it in Android, Google's Android documentation as well has use cases and examples and things like that as well, where you can learn it, and it's really quite nice if you want to learn it from an Android perspective explicitly as well. But yeah.
Are there any further questions from the people on the call? You can either put it into the chat, or you can unmute yourself if you want to.
I just had one more, if that's okay. Can I just ask if Kotlin can be used as more than just a Java replacement? Can you use it for, say, developing front-end web applications, sorry?
Yeah, you can use Kotlin for client-side and server-side web applications. It tries to provide interoperability with existing module systems and provide the same functionality in the standard library, whether targeting JavaScript or the JVM. So it can be used, for example, to interact with the DOM elements, or you can use it to interact with server-side JavaScript like Node.js.
Would it be fair to say that maybe the JVM offering is probably the most mature of them all? I mean, I don't know about that.
Yeah, I think that's where it started, and I think JetBrains has definitely focused a lot more on that over the years, and they're adding in things more recently. So I would say, yeah, from the JVM side, it's definitely more mature. There's nothing else. Thank you, guys.
Thank you, Ruta. It was wonderful.
Thank you. Thank you for having me and listening to me.